Okey-dokey, apply chain rule to derive faster. First bit. Okay, based on what we know, if we wanted to derive that, what do we have to do?
Expand it.
Right, guess what you're going to spend the next minute or two doing?
Not expanding it.
Bad luck. Go. Let's see if you can actually do this
Oh,
accurately on the first shot.
Yo, can we get on cash?
No. There's a couple different ways you could go about it.
So everything will be full stop.
Gotta stop, gotta stop, gotta stop.
I'm so glad people found easier ways, man.
Oh yeah.
Yeah, that's just it. Okay, there we go. Okay, right, and then just duplicate it, because it's the exact same thing, right? So that's, that is, times whatever that is. That's what I did here. Okay, so it's on the head. Yeah, that's what I got, and that's what I got. We're not going to have to get through all of these, surely.
Not meant, no, just the first one to expand. Just to convince ourselves that it works.
Yeah. Assuming we expand right.
Everyone's still going? Or? Yeah, just expanding that. Manually, yeah. You got a result? Checking it.
Yes.
Oh, that's trouble. Yeah, you may as well call you that. If you've ended up expanding it, feel free to derive. Because that's the ultimate goal. We almost there?
Oh, yeah.
Yeah, look, 1, 2 done. Still going, still going, still going, still going.
I just finished writing the ring.
What?
I just finished writing the ring.
Oh, you're joking. No, you're joking. Okay, good. We're joking. You're joking.
Please, it's okay. I'm not taking
Are you
it
serious? No. Come on. You don't know?
Oh, no, I just don't know if it's right.
Yeah, exactly.
Yeah.
I think.
24.
Is that right? No. No, it's not. No. Oh.
My name just keeps being a bit more.
Yeah, so yeah. And what's this? I feel like it should be 6 though. Yeah, what did I just write before? I lost it already. 24. So what you got?
Yeah.
What's wrong with that? 216. There we go.
Oh, bro, that's not wrong.
216?
Yeah.
You'll get. Can't do that.
Six. And then 81 positive. So we have? No, that's
No,
not the last one.
To the X.
That.
Yeah. Someone like
Oh, I did the wrong way around. Oh, I did that one again. Oops. Sorry. What about, I'm on the other. 216 again?
Yeah.
No, there you go.
Why do you get the
Go.
216 squared?
Beautiful. The way I did that quicker, I will teach you later this year. They don't work for nice simple ones like that anyway. Okay. Who got it? 1, 2? Almost. Who made one error? Yeah. Was it a benign negative error or?
I made that, I corrected it.
Okay. No, but you found it before I wrote this. Yeah, that still counts.
I just couldn't times 12 by 12.
I got 70. I got add 72.
At the end.
Yeah, that's
Other
good.
than that, everything was good.
Yeah,
Okay, you did well
that's good.
Um,
I think that's like an
right. Now, based on our survey of a quarter of people got it right on the first shot, right? Do we want to avoid doing that?
Yes.
Yes. Okay. So, by the way, let's take a derivative really quickly. 64 is minus 290. What's this for? No, 288. Plus 432 minus 216. Okay, so that's our derivative that we're ultimately going to get to.
Yes.
Alright. Do we have any idea what that looks like?
Nope.
You've got a tiny idea.
Oh, the shape of it.
Right, the shape is. Okay. Right, cheap, right? It's going to do something like that. Okay, great. Other than that, numbers are big, that sucks, don't want to do it. Okay. Well, now we get to the lovely magic of things. We are going to re-describe this thusly. Okay. So, when you can apply chain, it's when you have a function inside another function. So in our case, we've got 2x minus 3, that's a function, it's a linear function, it's still a function, inside to the power of 4. So, for us, g of x is the outside part. We're going to describe that as x to the 4, because it's something to the power of 4. Now, inside part is... Oh. The derivative is now fiddly bit. There's a couple ways that you can reorder this, but it doesn't make all that much difference. But, sorry, a couple ways you can write it, right? Oh, I wanted to change colour there. Hang on. So, group is
Is this the chain rule?
yeah, going from there to there, that's the chain rule. With lovely colours. Alright, so, what does this end up saying? So we've got G of x and h of x defined. We're going to need h prime of x, so in other words the derivative of h, and we're going to need g prime. Okay, fine. G prime of x is
4 is 2 to 3.
right. H prime,
2.
just 2. Okay. Now we're just playing mix and match. This thing. Okay. H prime, nice simple 2. I'm going to put brackets around it just so we're clear where everything came from. Cool. G prime is 4x of 3. So we have 4. The x is just a placeholder. So I'm going to leave space to the power of 3. And then in that placeholder goes h of x, which is 2x minus 3. Yep.
How you did the derivative function? Just the function of x, you just read the function of x.
Oh, thank you. That's fine. Thank you. Beautiful. Okay. Is everyone happy with where everything went and came from? Maybe not so much why it went and came from, but like everyone can play the mix and match game.
Yeah.
Everyone's happy about that? Yep? Okay. So, why exactly this works is a little bit fiddly. But, oh, we should neat this up. By the way, that's just multiplying with that. Cool. Okay. I will give you the why. To be honest, for you guys, you're not going to care. Right? Which is the short version of it, but until you get into things much later. The gist of it is, we need this in other notation, so dy dx equals dy d, which one do they usually use for chain rule? Is it u? Yeah, I think it's u. Okay. Where y would have equal, what's this? U inside of, what is it? Function of u, where u is a function of x. I'm missing something. What am I missing? This gives this. What am I missing? I mean, I can just do u substitution from partials, but
So is that the simplified version of 64x cubed, blah 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 blah.
so, sorry, say that again, where are you looking?
So 8
Oh,
brackets.
this and that, are they the same? Yeah. Well, so long as we did this right, yeah, they should be the same. We could verify that. 8x cubed, what's this? So we've got, what do I need? I need 1, 3, 3, 1. So, what am I doing? This twice, so 4, 12 minus 36 x squared. This is how many am I doing here? 2 is this going to be plus. Is 18, and then my 3 is 54, isn't it? And then minus 27. minus 24 and 48 to 8, 8. Yep. 432. Yep. And was the 216. Yep. Yeah. So yeah, works out the same. Alright. Now, to go back to this, all this is saying is you've got y in terms of x, you want to derive it, so dy dx. That's the same as if you take the function of y, derive it with respect to part of the function, and then multiply that by the derivative of the part of the function with respect to x. Now that's a whole lot of words. All that's saying is that. So we take, I'm going to say the part of the function is g, so I'm going to derive g with respect to the rest of the function, which just means treat all of the rest of it as though it was just x. So in other words, this becomes g of x, well that derivative is x prime, g prime, which is what we did over there. Cool? So that's this bit, but we keep it inside, because we were treating that as though it was x, so it just stays in there. And then multiply by the other bit with respect to x, so the other bit here, derive that with respect to x, that's just h prime. Yep.
Are we just naming G because it's something, or does G have meaning?
No, G doesn't have meaning. It's just the next letters in the alphabet, F, G, H. No particular meaning. Now, this idea doesn't particularly matter for you in methods, really, unless you're going for 40 plus sort of thinking, then it might. Even then, it doesn't really. You can do a little bit of stuff with it, but you won't be able to do much with it for now. In special, it definitely does. So it's more, I'm going to tell you this, you're going to put it in a book, and then in 2 more years, if you do stuff at uni, you'll be like, oh, okay, now I kind of get that. But for now, this is almost certainly going to cause more trouble than it's worth. So I'm going to suggest that you just think in terms of that, just for the operational side of it, just for being able to clonk through. But that's the basic gist of why it works, because you're doing, okay, how does this bit change when I derive? How does this bit change when I derive? Okay, I put those 2 things together, and now we can do it. Right. By no means is this supposed to be, like, intuitive and obvious. Right? It's one of those things that spits out. The way that I'll say this is I say, okay, derivative of the inside multiplied by the derivative of the outside with the original inside. That's how I'll say it out loud, just because it's easier than saying h prime times g prime of h, because that's pretty meaningless, doesn't help. Cool, so now we've got another guy. Do you want to expand that? No, so let's not expand that then. Instead, let's define our pieces. Okay, g of x is the outside function. For this thing, not you, because I know you know how to do it already from special. For this, what's my outside function?
2x to the power of 5.
Right, 2x to the power of 5, yeah? As a general rule, it's whatever isn't in the bracket. Cool. Next part, I need my insides. What are my insides? 3x plus 4, right? Usually whatever is inside the bracket. Beautiful. Alright, we need the derivative of each part. Derivative of blue. Anyway.
10x to the power of 4.
Derivative of green. Right, nice simple thread. Cool. Alright, so my overall derivative. Okay. H prime. H prime is 3. I'm going to put brackets around it, just because that's usually a good idea. Just in case things get more complicated. Next bit. G prime is all of this, but we have to remember this is containing something, so we go 10 with space to contain 4. And then green h of x, 3x plus 4. Cool. Everyone's happy with mix and match? Yep. And now it's just neaten up what you can. From there, if I was to expand it, would it get any neater? No. So should I bother expanding? No. I'm just going to make life difficult for myself. Beautiful. That's that. Incidentally, do we know what that one looked like?
Kind of.
Just very vaguely, we knew it was some kind of cubic.
Yeah.
Do we know what that looks like?
Yes.
Yeah.
Yeah, we can draw that one. So this is actually more useful. Right? Same thing, back here we knew what the original looked like potentially, and we can draw this. If we were to expand it, that would actually make it worse for us. So this is a really handy thing. You want to keep things back. These are a little bit different, but still the same idea. So, does anyone want to volunteer to have a crack at it? Yep, go to Jeff.
We have to find out what g of x is,
Yeah,
and that
okay.
will be the outside function. So this will be 2 divided by something.
2 divided by something? Okay, so 2 over
By x.
x. Sure.
And then we have to find out what our h of x is, and that should equal 3x minus 2.
Very good.
And then we derive that, we derive both those terms, and we get g prime of x, and that should be 2x to the power negative.
Okay, so this is 2 times x to the negative 1.
Yeah.
So
So,
that's
so
my
it'll be negative 2x to the power of negative 2.
Hang on, I didn't hear it, sorry, because I was raising things. Give me 2 seconds. So that's the same as that. Okay, go again. What did you say?
So it'll be negative 2x to the power of negative 2.
Fantastic.
And then for h prime of x, it'll be 3. And then from there, you sub them all into your trading formula, and you should get 3 times negative 2 brackets 3x minus 4 to the power of negative 2.
Champion.
And then 3 times negative 2 is negative 6, so you should be simplified with negative 6 brackets 3x minus 4. So
I should have done this as well. Out of the 4, here it goes. Good job, TJ. Oh, is there another way of writing that?
oh, yes. Well, I don't know. Oh, yeah. Is it, yeah.
Negative 6 over 3.
Which one's the proper way? Oh, which one's the way we should do?
Depends. Do you know how to draw that? Do you know how to draw that?
Ah,
Then for you, that one's better. Cool.
yeah.
That's the only reason why half of this, why I suggest to you write it with positive powers, because we're used to looking at things with positive powers when we're graphing. This is the exact same. So if I look at that, I can go, oh yeah, that's right. But even for me, I'll still switch from that to that, purely because it just helps for some reason, human.
There's a truncus graph C.
It is.
I thought it was, I think it started with it was truncus or
Hyperbola?
yeah.
Yeah. Yeah, that one's truncus. Cool, this guy's a hyperbola though. You can see there's only carrot one on the bottom. Good jewel. Anyone want to have a crack at the next one? So do you want me to give you a minute to see if we can all do it? Yeah? Alright. Have a minute.
But they're gonna see big Andrews, yeah, the big one.
Don't worry about the ones on the right. Illustrative.
That's not negative times negative, that's negative times positive.
Negative 5 over x.
It's just a positive monograph. Yeah, but the negative 5 is still negative. It's not a, that's, you're saying negative 1 times negative 6.
I think this is as good as it gets. So that's
Negative
good.
negative 1 times negative 1, that doesn't work like that.
I think these guys are cross-referencing. All right. Anybody else want to volunteer? No one's confident?
I could try, but
You already got to go. Okay, go.
Negative 5 x.
Yeah, so it's not negative 5.
X to the next one. Yep. Okay.
Meanwhile, hx is.
Yeah, that's what I had.
I don't even need these brackets. I don't know why I put those in there.
You said what? Oh, no, I wrote that in the
x squared minus 6x.
Oh, yeah, that's right.
Yeah.
Yeah, so you can see what
Cool. X.
Yeah.
Oh, I'm just checking. 2x minus 6. Suitable. 2x minus 6.
You just realised you dropped a bracket.
No, like.
You dropped the sense.
Oh,
And now.
And then x squared minus 6.
So how did you get to 10x to the power of negative 10? Did you do this in
Just
your
this.
Yeah.
Derive it. So the power comes down by 1. Negative 1 goes down to negative 2.
But what about 5, negative 5 to 10?
Oh wait, yeah, no, this should be a 5. Oh.
yeah.
Yeah, sorry. Cool. Sorry for that. Yeah. Yep. Cool. Equal.
Oh.
10x minus 30.
No, you did it wrong. No, sorry.
X squared minus 6x.
Did huge stuff. No.
Cool. Anyone happy? Yeah, happy. Guys up the back are happy? Yeah? Okay. Okay, here's my next question. Are we done?
No.
No, because why?
because
Because I asked that question.
it's if you need to do this.
Anyone got any ideas? Factorize what? Top and bottom?
Oh, simplify.
You can factorize the top.
Okay, could factorize the top.
Take out a factor of 10.
Alright, so I could do 10, x minus 3 on top. What do you got on bottom?
It's
Next
3,
minus.
negative 3, negative 3.
Yeah.
X equals
Is it
positive
X?
3 squared. Negative 3 squared.
Surely it's,
So it's that, and then this whole thing
squared.
is squared.
Why is this?
Divided, so that would be x minus 3 squared. 10 over x minus 3 squared.
10 over,
X minus 3 squared. Oh.
how many x minus 3's is
It's
this?
cubed, it's cubed, right?
Right, so it's cubed on bottom. Cool. Alright, which one of those is best?
The bottom one.
Probably bottom one.
Wait, why did you decide to develop this?
Because this, I've got 2 to the power of 2 and 4, alright? So I've got 4 on the bottom, 1 on the top, so I got 3 on the bottom.
4 on the bottom, 1 on the top, and you take 1 down.
Cancel, yeah.
Yeah.
You do. Cool. Alright. How do we know if that's remotely correct?
Ask Mr. Joe. Or you expand it.
Expand it? Expanding it would not help. You just get it bigger.
Oh,
Does
does it?
Drawing's not a bad idea. I'll take you. Drawing it won't help per se. Oh, it could, but you've got to go one step even earlier than that.
Can you just sub in numbers and, like, if they come out the same, then sure.
They can't be the same. Sorry, not if this is equal to this. I'll give you that all of the red is equal.
Oh, okay.
How do I know that this is the derivative of that?
No. Integrate.
Okay. Can you integrate that?
Yeah.
Oh, wait, is there another change?
You can integrate that?
Is
Oh,
there a
through
change?
spec. Not in methods, you're not expected to be able to integrate that. Okay. What kind of function was that?
That's hyperbola.
Trungus, it's got an X squared on the bottom. Okay. If I go from, what's this?
Hyperbola.
That's hyperbola. Okay. If I derive a hyperbola, what do I get?
You get a x
Trungus,
Oh,
right?
you truncus, and if you derive a truncus, you get whatever that thing is called.
Okay. So this thing is essentially just got x to the power of -1 in it. Right? Gives me x to the -2. So if I've got x to the -2, what should I end up with?
X to the -3.
What's that?
X to the -3.